Good morning, welcome back to Tony's Top Tips Workshop. What I'm going to do today is, I've had some feedback from my other social media sites and YouTube. People just generally requesting, well, one of the questions is, why do you use an offline controller? Well, I prefer to use them on my professional one here. It's a DSP, excuse me, which is an offline controller. It's just like a big keypad really, and the reason why I like it is, once you've done the software on the PC and you load it on a chip, only connection between your CNC and the program is the actual offline controller. Now I see it a lot on other sites where people's been using the PC connected to the CNC and it's dropping in and out. USB's causing problems. It's holding. It's not doing the, and a lot of the time it's the connection between the PC and the CNC. It's not always the actual software. It's the connection issue. You only need it to drop out slightly and the program will stop. And some people have, they explain it that the USBs have to be set not to go in like a sleep mode or something. Well, I use, since I've got the 4th Axis, it comes with the offline controller, so I tend to use that, do the software program, do whatever I want to do, and then once I've completed that, I put it on the chip, put it on the offline controller. The only connection that could possibly drop out is the one from the offline controller. You can stand and watch it. It's easy to set up, and because it's connected so close to the machine, some people have like 3-meter cables. Well, anything can happen in the quality of the USB cable and everything. It's just the way I prefer to work. Obviously with the laser engravers, I don't have an offline controller for those. If I did, I would use it, trust me. But it's just the way I prefer. It's my personal view. But going back to the request that what's it like at doing spirals on the 4th Axis, and I said, I mentioned about, I said, well, I've not actually completed any, but I'll do a simple program and show you now. What was on about in the previous videos is using larger stock. Now I'm not a great believer in clamping a large stock in, well, to a maximum. I think it's about 30mm you can get in that chuck without the chuck jaws actually catching. And what I tend to do is put a plug on. It's on with the Mitre-Lock glue, so it's instant. Once you've centralised it, and within half a mil, you're not bothered really, because as it turns, if you're doing a rounding toolpath, square to round, once you've set it, it will automatically find its own centre, and then once you've done that, you'll leave it in the chuck, and then you'll do your spiral toolpath. Now that is, you can see that is a spiral toolpath that I did. Now there is 2 toolpaths there. There's the deep V, like a V carve, but it's a profile toolpath, and then there's the other one. Now because it's not a cutter change, then what I initially do is, the first toolpath I'll do is, once I've stuck the blank on, as you can see, that's the 25mm diameter blank. It's centralised and it's got the centre hole for the tailstock. Now this is not square. This is what I was on about. You can do oblong material to a certain degree, is because when you put it in the machine and centralised it, this is 31mm by 29. So always remember, when you're doing your Z0, that you put it in the settings that you actually want it to clear quite a substantial amount once it's zeroed off, so you have to alter that in the setup. I'll show you how to do that. And then all that is it rounded it off to the 25mm diameter that I wanted, and then I changed the cutter, took it back to the zeroed the Z-axis again with the new cutter, which were a V groove cutter, and then there were two tool paths, and they were both, because of no cutter change, I could tell the software program, which is Vectric's Aspire, to do the large one first, the V groove, and then with the same cutter do the one in between. And I haven't cleaned that up. That's granted it was with a new cutter, but as you can see, that's just a simple spiral, and that's only a 2 flute spiral. I mean, you're limited to the diameter 25, how many you'll get on, and the depth you can get, because what you don't want is the spirals running into one another, because you try to put too many on. But that's it, that's the plug at the end, and that will just knock off, and I can reuse that. So I can put that on a 2-inch piece of stock, put it in the centre, centralise your tailstock, and it'll, once you've set the machine up, it'll just run. So I did the rounding toolpath first, and then I created a spiraling toolpath. So yes, it's very good at doing. It's not the fastest, because what you find out is, because it's held in the chuck's on the right hand side of mine, so when it does the toolpath, it will actually start to whatever depth you've passed. Now I was doing this at 1/2 mil depth each time, so that it would plunge in 1/2 mil, do its cut, and then lift up, go back across to the start again, plunge in another 1/2 mil up to the depth that I wanted, which were 3 mil. Now in order to rotate that spiral round there, the software tells you it's 8 turns of this blank to get from that point to that point. So 8 turns. So obviously when it comes back up, it tracks back across and your chuck revolves backwards. Then it finds a start point again, plunges in another 1/2 mil, and then goes across. Now on my Pro machine, I can set it so that it will plunge in, cut, and then plunge in and cut again on the backward stroke. But whether it's me that's just not programming right, I don't know. But anyway, that's what it did. I left it running, and you've got to remember that's a 500 watt spindle. It's not the best of spindles, but it's the cheapest way than going out and buying that I wanted anyway. I didn't want a router, a Makita router on it, and with a Makita router you could probably plunge in a lot deeper, you know, maybe a mil and a half. So it'd only take 2 passes to get that you wanted. But you've got to remember that it's best to take less off than try to take more off, if you get my drift on that. So that's how that was done, and I think it's a pretty good finish. But what I'm going to do now is I'm just going to go through the toolpaths and how I set the program up, and then I'll show you the machine cutting it. Right, here we are at PC. Right, I've got Aspire 9.5 open. So what I want to do is create a new file. Right, so as you see here, we've got the rotary, and I put it at 90 mil. That's not the length of the blank. That's not the length of that. that is completely different. It's the length from the tip of there to here. That's the working area that I want finished. So it's 90mm by the diameter, which is that, and I've checked it, it's bang on 25mm, so it's pretty good, is that? Well, 25.01 on micrometer, so that's not bad, is that? 25mm. The cylinder axis is starting off at the centre and bottom left, which is, as you can see, and we'll click OK on that. Right, what we're going to do now is go up to your gadgets, and we're going to create a rounding toolpath. Now, rounding toolpath is taking a square blank or a round blank and turning it down to the diameter that you required. This is definitely not square. So, and I've got another blank identical to that, and I'll put that bottom piece on the plug on the end once I take it off here. So what we're doing now, as you can see there, is creating putting the details in a square blank. So you always set the maximum size of square blank, and when you might it with 29 one way and 31 the other way, so you would take it to the largest, which is 31mm. Optimised raster along cylinder machine. Right, what that means is it'll go, once you've set your 0, and I set it excuse me, start point and top corner. I always do a top corner, I don't know why, but I do. And you zeroed off, it will turn it round, right round, and come back on itself to the point of start, and then it'll do it on a top corner, because the top corners, the corners need taking off first, because obviously if you started there, when it come down there, it'd be taking a massive cut off. So the software automatically does, it knows that where you've started it, and it'll start to take the corners down. It'll do this like that, take one down, then it'll move around to another and then it'll travel across backwards and forwards until it's got down to the 25mm diameter. Okay, and that's all that's doing, rounding toolpath. So we know it's done that. Now, because we've actually set the details here, you have to select a tool for the machine. So you select now. For this, I use like it's like how can I say, it's an end mill basically, but it's not a spiraled end mill like you can see there. It's two fluted, two cutters, one on either side. It's a bit like a plunge router bit that you'd use on a worktop, and it's a 6mm one, and I find it quite good for clearing it, and especially because it's taking it's only taking 1/2 mil off at a time. It's quite easy for the machine to do. So you set your cutter, cutting parameters. I've left everything standard really, because I can alter the speed of mine, so that's not an issue. But the pass depth is 0.5 mil. I've cut it down to 0.5. With a Makita you'll probably get maybe 1.5 mil, maybe slightly more off with a right cutter at a time, so it'd round it off in no time. But you know, if you've got the standard stock spindle in, then I would seriously think about taking it off a little bit at a time. You get less flex and movement in the machine. So you set that, and that's done. Okay, now you don't see anything there, but if I go into 3D mode, there you can see it. You can see that. Them's the number of passes. It's quite a lot of passes really. Then you go over to your toolpaths. Now it's already created the rounding toolpath there. So with nothing else to do except you know, save it as a toolpath. Right, save the G code. So obviously it's Sainsmart wrap. Save toolpath, and then we'd save the toolpath on the machine. I've already got mine saved. You'd save it, name it what you want to name it, save it on your PC, and then once you've done that, you can transfer it to your chip, put it in your machine, and then I'll now show you how to set this up then with the machine. Right, here we are at work table. This is what I was trying to get through. Now that blank is on by Microlock glue. It's quite strong, so in order to reuse this, you just put that in there and give it a tap. There you go. You see, it's off. There we go. You see, it's come off. Sometimes you need a little bit of cleaning up, but I'll just give it a take the old glue off. There we go. So it's clean. So that is ready to put onto the new blank, which is here. As you can see, it's centered for the back, and I'm just going to pop that on there now. So, and what I do is just take my little tape measure, 3mm. You can do it with eye, to be fair. Yeah, doesn't really matter. Right, this is simple Microlock glue. Okay, so all I'll do is spray that one end, little dab on there, and then just, I know roughly where it's got to be. Pop that on, and you just hold it for a few seconds. Okay, so that's on central, roughly. Doesn't matter too much because it will automatically, I always check to make sure that it's near enough, and then once it starts to, it will automatically true itself up when you get the round blank. It's taking the corners off and it goes down to the central body. It will automatically do the backwards and forwards, and it'll, once you've done that, you're leaving it in the chuck to create the spiral, so you're not disturbing anything, and it'll be perfectly true. Right. Here we are at the machine. So that's the blank, and the blank is 15mm depth, 25mm round, 15mm deep. That will, when it's in the chuck, clear the chuck jaws. Right, so we pop that in there, move the tailstock back. As you can see, you don't have to be too until you put it in the tailstock. Screw that up. There. You always just give it a tighten and then just slide back off. Lock it in place. Then with the chuck keys, just tighten that up. That is tight now. As you can see, there's no movement, and that'll stop quite adequately on there. Okay. So right, first thing we want to do is zero the probe. So I have a lock and it's 50mm, exactly 50mm. So we'll take it down to probe. There we go, probe. There we have. We're set up with the probe. Touch off. Then we go back here. Probe. Touch off. And there we go. Touched off. And that's working from the centre out. Then we go back here, and then we're going to go to X-axis there, and then what we want to do is move it across to this end. Then down to Y minus and bring it towards us. I've got it centre to the edge of that. Okay, just move that X over slightly. That's good, that. So that's set, and then we go down to start your job, and then X-axis, it's at the top, you need to zero, and then down to Y. You can zero both, but I do it individually. Zero Y, and then go to your A-axis and I zero that. Okay, so I now know that everything's zeroed and we've done the Z probe touch off, so everything's set. You go down to your file and rounding toolpath, which is that one. So I would literally click on that, then you get rounding toolpath, then you would click on that, and that would start your program off. And all we have to do now is set the program running. It's now on its last corner. what it's doing now is it's going to go reduce that diameter now down to the 25mm. What you've got to remember on this is I'm only taking 0.5 off. With a stronger routing motor like the Makita, you'll probably be able to take a lot more off. But work to its limitations on the machine. It might take time, but it gets there in the end. There's no need to try to rush everything. And I like to use at least a 6mm flat bit because it tends to do a better round. Right, there you are. That's the finished rounding toolpath. And that was set at 25mm. So if I put the there you go. So you can see how close it is. About 25.1, sorry. That's bang on 25, so you can see it's pretty accurate. So what I would do now is actually leave that in situ because that's already trued up to the chuck. I'd just make sure it was tight, and it is. Change the cutter. I'd move the cutter back on the Y, 0 off with a new cutter in, a V cutter, and then set it back to the 0 for the Y axis again, and then job done. And off with the next program, which is a toolpath. Same tool, but it's a deep cut toolpath and then a shallow one. Well, welcome back from the workshop. I'm upstairs now, and I've do excuse the noise, I've got the 3D printer going for my grandson. Now that video that we've just concluded is the rounding off toolpath. The next video will be to cut the spirals. I'm hoping that it enlightened you a little bit. It runs without any hiccup from the offline controller. It just starts and it finishes. There's no dropping out, pausing. It just does what the program's designed to do, and it does it quite accurate, really. So as I say, till the next video, I'm hoping to be doing it in the next few days. As I always say, like and subscribe. I try and answer everybody, and the feedback I'm getting at the moment is absolutely fantastic, and I thank you all for that. And as I always say, until next time, be careful, be safe, bye for now.